Welcome to this video. This video is an answer key for CER, Claim Evidence Reasoning, Test PS2 Learning Set 3. So it was for our it was for our first science book of the year, but it's the second one in the series. The first one is used in 6th grade. So Learning Set 3 means it's the end of the book. And mini just meaning it's not a full-fledged CER, it's more of a quick mini CER, something that you're going to be able to finish up in a few sentences. And you'll see what I mean as we go through this. So anytime you write a CER, you first have to know what you're writing a CER for. So here's the question. Is mass a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and cupric chloride? So one of the first things I always suggest you do before you write the claim is check over the scientific principles and then look at the evidence. So let's look at the scientific principles. There's only 3 to choose from. So number 1, chemical energy is transformed into other types of energy during a chemical reaction. Well, if I look at it, is mass a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and cupric chloride? So it does talk about being converted. So 1 could fit. Number 2, an object's chemical energy increases as its mass increases. And something should be going off in your head. Ding, 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 ding. Okay, increases as its mass increases. If I look up above, up here it talks about is mass a factor. So definitely scientific principle number 2 will be used. And then 3, the type of substance an object is made of influences the amount of chemical energy. And you look up above, it's talking about mass being a factor. So number 3 really has nothing to do with it. So we're going to look at these later, but one of the things you're going to find out is that number 2, if you just used the 1 scientific principles throughout this whole CER, you're going to score at least a proficient if you do it well. If you want to get an advanced score, you would need to use these both, number 1 and 2. But definitely number 3 is not used. So if I was you, I would just take a pen and I'd cross that off because you know it's not right. So go through your CERs, and rarely do I look at CERs and see people crossing stuff off. But why not if it's not being used? So now let's look at the data. Now this data should look familiar. We did the lab in class. Every CER we've done this year, you've done the lab, you've worked with the data, and that should make it easier for you to do. So again, let's look. Is mass a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and cupric chloride? So if you remember in experiment number 1, we had 5 grams. We put in 5 grams of cupric chloride. Sorry, stumbled there a little bit. And that was a blue powder. You measured it out and you put it in water. You mixed it up, you took the temperature beforehand. Then what you did was you added some aluminum foil. In the first time, you just added 0.5 grams of aluminum foil. And the temperature changed. In fact, it changed 32.5 degrees Celsius. Now, if you remember, on day 1, I told you that it's important that you do well for this experiment because it's going to set up the next day's experiments. We did them on a Thursday and we did them on a Friday this year anyway, so it might be different in other years that you're watching this video. So what did we do in experiment number 2? Well, we used 0.8 grams of aluminum foil. Remember I told you, at least for me, this may be different for Mr. Phillips, he may have used 0.75, but the balances in my room didn't go out to the nearest hundredth, just to the nearest 10. So we raised it up to 0.8. You did everything the same. You added the cupric chloride to the water, you mixed it up, you took the temperature. Then, and that's why the temperature might be a little different, because water might have been a little bit different temperature each day, even coming out of the faucet. But now you added 0.8 grams of aluminum foil, and look how much the temperature changed. In fact, it changed 40.9 degrees Celsius. Do you think that's important? Well, if we back up, remember, is mass a factor? So here we had 0.5 grams, here we had 0.8 grams. So those two seem to look pretty good. How about the last one? Now we use 0.5 grams of steel wool. Wait. So let's back up. Is mass a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and cupric chloride? This is steel wool. That's not anything to do with what we're doing. So again, do you go through the data before you write the claim? Don't just start writing the claim right away. Go through the scientific principles, go through the data. So this is the one that you're going to definitely want to use. You're going to want to compare this to this because we changed. Is mass a factor? Here was 0.5, here was 0.8 grams. So we increased it by 0.3. So definitely this is what we need to use. Now that you know what scientific principles to use and you know where the data is, now we can start by writing our claim. Remember, claim, just one sentence. That's it. It's got to answer this question. Some of you write claims, and I'm reading your claim, and I have no idea what question you're answering. You're not answering this right here. So you've got to answer this question. It should not start with yes or no. So even though it says, is mass a factor, you shouldn't just say yes, no. Now, it should not start with typically one, but if you said, when you gave the answer and if you put yes in front of it, for example, here's yes, mass is a factor in determining, I'm not going to mark it wrong, but what it really means is it doesn't want you just to say yes or no. It wants you to explain yourself. And it should describe the relationship between the dependent variable and the independent variable. So the dependent variable is going to be what you manipulate, and as a result, the independent variable is going to change. So here's the claim. How did you do? What did you write for a claim? So here's the simplest answer you can have, pretty much, and get a proficient. Mass is a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and copper chloride. Now, did you notice I basically just repeated the sentence up here, but then I answered it. Mass is a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and copper chloride. So when you answer the question, incorporate the original question into your answer. That's it. That's all I need for proficient. Now, if you want to advance, you can go beyond that. Still one sentence. Mass is a factor determining the amount of chemical energy that is converted when mixing aluminum foil and copper chloride. As more aluminum foil being added, or was being added, creates a higher temperature change, indicating that more chemical energy converts into more thermal energy. Just a little bit more complicated, brings more into it. It's more of an advanced answer. This is all you need, folks. If you have this, I'm fine giving you a proficient answer. You don't have to go above and beyond. Just give me the bare minimum to get your proficient answer to make sure it's correct. So you can't have answers like yes, or, mass is a factor. You've got to go beyond that. Mass is a factor in what? So make sure you have enough details to get it correct, to make sure you're answering this question. So the next thing you're going to hop to is your evidence. A lot of times I'll say, why don't you write up your evidence first before you even write your claim? And that's not a bad idea. You probably could have done that, and I probably should have done that. Remember, evidence has got to be sufficient, but you don't have to go overboard. It's got to be appropriate. It's got to support the claim that you've made. Don't just have data in there that is good data, but it's not good for the question you're answering. And use both qualitative and quantitative whenever possible. This is the one a lot of people miss because they don't include their numbers, which is crucial for doing well here. So here is what I would consider to be a proficient answer. So these are the two that we talked about is being relevant, as being needed. So when we added 0.5 grams of aluminum foil to the 5 grams of copper chloride solution, the temperature of the water increases from 21.6 degrees Celsius to 54.3 degrees Celsius for a net gain of 32.5. So did you see what I did there? I'm just going to fix this quick because I used 0.8 grams. Mr. Phillips used 0.5. But did you see what I did? All I did was explain this and how when we added the copper chloride 0.5 grams, it changed to this. That's it. And we had a net gain. So I'm just explaining my data here. I'm not making up any data on my own. So when the second bullet point here is when we added 0.8 grams of aluminum foil to the 5 grams of copper chloride solution, the temperature of the water increased from 21.3 degrees Celsius to 62.2 degrees Celsius for a net gain of 40.9. So again, all I did was explain, now I had 0.8 grams aluminum foil. When I added the 0.8 grams, the water changed from 21.3 to 62.2 for a net gain or a net increase of 40.9 degrees Celsius. All I did was explain the numbers that I used. I didn't make anything up. I didn't need to know anything. I just needed to explain this. Now you might say, okay, big deal. Why is that data important? So here's why. The result of adding an extra 0.25, and I'm going to change this over because Mr. Phillips might have used that, but we used 0.3 grams of aluminum foil. What was the result of adding that extra 0.3 grams? Well, it increased by 8.4 degrees Celsius. So I subtracted this. Now, you could have done this differently. You could have said, well, by adding 0.3 grams of aluminum foil, the 0.8 grams had a larger increase, 40.9 versus 32.5. So you didn't necessarily have to have the 8.4, but I explained what's the difference, why the difference. And that data, and this is hugely important because this is what actually explains why 0.5 grams did not produce as much as 0.8 grams. And the increase in mass, and that's what you're looking for. Does the increase in mass result in a different temperature? Yes, it does. So again, did you see how I just have 3 sentences? That's it. Now you might look at this and say, wow, Mr. Rattoon, half the page is filled up with words. Well, remember, it's a notebook file. If I look at the size, this is a size 23.75. So you're not going to write that large in your paper. If I put this at a size 12 font, which is more typical of what you see on paper, that's it. That's what it's going to look like. If you were typing this out on paper, this is how large it would be. It's not that much. So go ahead and make sure you know how to find the evidence and correct your work if you needed to. And finally, the reasoning. Remember, the reasoning, it shows how or why the data counts as evidence to support the claim. So basically, it's tying it together. Provides the justification for why this evidence is important for the claim. It helps substantiate the claim. Now, this is the thing that's the great mystery for me. And every time we take a CER test, I tell you, you have to have scientific principles if they're appropriate, if they're there. Sometimes you won't have access to scientific principles, but you're still going to have a reasoning, a scientific reasoning why the claim fits. But here I'm giving you scientific principles. If you don't have scientific principles, it's an automatic failing grade. You're not going to be proficient if you don't include them, if they're there. So the great mystery is why I remind you every time I tell you, use the posters in the back of the room and we give you access to all this stuff. And probably about 20% of you, when you take the CER, you won't include the scientific principles, even though you know you have to have them. So it's better to at least attempt to have some in there and use them than to say, well, I don't know how to use them. But let's look at those scientific principles again. Let me go back here. We already figured out which ones. So if you're doing this paper online, just copy and paste these in there. And you don't even have to rewrite them out. Now, if you're doing it on paper, you're going to have to write them out. Now, here is what I would consider to be a proficient answer. Mass is a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and copper chloride. This is my claim. That's all I have in there. It's my claim. So I go back up. I'm not making anything new up. I'm just restating my claim. Now, scientific principle 2 states, or SP2 states, that an object's chemical energy increases as its mass increases. Again, this is nothing new. All I did was I went back up. Here's my scientific principles, and I just copied it down. Now, a couple of things I want to point out. By saying principle number 2 states, basically you're saying, hey, Mr. Rattoon, hey, Mr. Rattoon, here it is. Here's my scientific principle. Because sometimes some of you use scientific principles, I think, but I don't know for sure because you word it differently, you word it funny. I'm not sure if I'm following you. Again, if you say scientific principle 2 states, it basically is a big neon sign saying, here is my scientific principle. So it states that an object's chemical energy increases as its mass increases. That's the first part. The second part is, why is that scientific principle important? Why do you need that scientific principle? Well, the chemical reaction between the aluminum foil and copper chloride created chemical energy that converted into thermal energy. The result of adding an extra 0.3 grams aluminum foil to the 5 grams of copper chloride resulted in an overall increase of 8.4. So did you notice where I got this from? I got it from the evidence. So here, scientific principle, I got it from the scientific principles that are on your test. This is the only part that you probably need to add to this. You need to explain why that scientific principle is the one. And that's the only thing you have to add to this section. You might say, well, there's a whole nother paragraph. This is just my concluding statement. Therefore, mass is a factor in determining the amount of chemical energy that is converted when mixing aluminum foil and copper colloid. As more aluminum foil being added creates higher temperature change, indicating that more chemical energy converts into thermal energy. Did you even need to have that? No. If we go back and I cross all this off, and I put a period right there, I'm fine if you have that. That would be a proficient answer. Now, if you want an advanced answer, you've got to go and you got to talk about scientific principle number 1. Now, remember when we talked about them, we talked about how if you included these two, both fit. But this is the only one you really need to be proficient. If you have this one, that's great. Now, the great part is if you included it and explained, that's where you're going to get your advanced answer. And it's just explaining that in order to get, even with mass, in order to get more, convert the chemical energy into thermal energy, you have to have a transformation of energy. And it just says a transformation is possible. So this would be for your advanced. So let's back up and let's count here. For my scientific principle, we went through those together. We crossed these off. So what did I have for a claim? 1 sentence. So that's 1. What did I have for evidence? I had 3 sentences. So I'm up to 4 sentences. Now here, 4, we got 5, 6, 7, 8, 9 sentences. So all that you have to do to get proficient on a CER in most cases is 9 sentences, or at least this one. Sometimes it might be a few more if you have a few more scientific principles, but 9 sentences. And when we look at this sentence you already used before. This sentence you copy right down from the scientific principles. And this is just a concluding statement, which is very similar to the one up above. So you're only writing 5 or 6 original paragraphs or sentences. So hopefully this review helped you better understand how to write a CER. Again, as always, if you have any questions, make sure you ask your teacher.